So we're starting into new stuff in algebra, which is kind of cool. But this new stuff's all going to be based on old understandings. I'll point it back to things that we've done before this year and even stuff you've done last year. But we need to get some vocabulary down in order to do some stuff with functions. So a function is a specific type of relation. And what a relation is in math is a relationship between a set of values. So what I mean by a set of values, as we talk about math, that would be like a relationship between x and y values. And we have seen these xy values as ordered pairs. We've seen xy tables, right? So those are all relations. A relation is anything between two values, for example, xy. So ordered pairs, anything on a coordinate plane that we can get ordered pairs from, that is a relation. All right? But what we're going to focus in on is a specific type of relation called a function. And a function is a lot like an equation. You will see stuff in function notation. So, you know how you've seen stuff like y equals 2x squared before?
Yes.
The only difference for this and function notation, which we're going to be using interchangeably but a lot lately, is function notation will look like this. The function of x. The function of x is y, okay? So these two things, they're really the same thing.
Yeah, I say that.
On the right is called function notation, and on the left is just an equation. But since a relation, it is a relation between x and y, this one we read as the function of x, meaning if x is this, what is y? Have you messed with stuff if you know what x is, figuring out what y is? Yeah, on a bunch of quizzes, right? Those xy tables that I was assessing your ability to do order of operations. Yeah, that was intentional, right? So you've already done some function work and you just didn't know it as that name. So, but we need to get a definition for function. A function has one or more variables and each domain must have exactly one range. And we're going to define domain and range. I know those are newish words, okay? In layman's terms or like simpler words, each input has one output. So thinking back to this function up here, remember when you put that in that t-chart? Anytime you put in -2, do you get different answers out of your function, or does it pump out the same thing every time? Every time you plug in -2, you should get the same answer, right? If you did it right. So that's what an input-output. Input is the x values you're putting in, the domain. Output is the values coming out, the range. Okay. So let's define domain and range. The domain of a function is all possible x values, and the range of a function is all possible y values. Another thing I want to point out is when you see a relation, when you see domain, and when you see range, and you saw a little bit of this in homework last night, they're going to be written with brackets, right? Did you guys see those brackets at all? So the brackets tells you that's the set. I'm bad at brackets, as you can tell. That first one was okay. So those things, when you write them, they're going to get written in brackets, okay? And then the domain and range, as a little note, sometimes they are written as inequalities. And we'll practice that today. The reason we would have is some graphs have a domain that goes on forever. And you can't list forever as specific points and such, right?
What is the last one?
Inequalities. So that's going to be all the wordy, old school notes kind of stuff. We're going to put these, keep these out because we're going to put these to work, okay? It's going to be new. When stuff is new, is it always like easy and really like fluid and like, oh yeah?
No.
Sometimes a little clunky? Is a little clunky a problem?
No.
No, just keep at it. You're going to be all right, okay? Keep at it. Be all right.
Like,
Let's talk about this set of numbers. When I look at this first set of numbers, the first question I'm getting on here is it a function? So let's just take a vote. Make your best guess. Raise your hand for yes function. Anybody think that's a function?
Yes.
Just make your best guess. If you had a guess. Okay, raise your hand if you think it's not a function. Raise your hand if you're like, I can't tell. I don't know what it... Okay, so let's look at the definition of a function. The definition of a function is each domain can have exactly one range. Each x value then can only have one y value. That's what that means, right? So check out these 2 points. Check out those 2 points. What's my domain of those 2 points? 1. So each domain can have exactly one range. This up here, this set up here is, by the way, that's a relation. So domain 1 has a range of -2 and a range of 3. So what does that tell me? Not a function. If I had an equation, no matter how many times I input 1 into my equation, I should get the same answer out if it's a function. So this is not a function. It's still a relation. Okay. Now, the domain is going to be all possible. Woo, bracket. Okay. All possible what values for the domain? X values, which would be -2, -1, and 1. I know I only said it once, but you should be writing this stuff down on your packet. Okay. Do you guys see where I got those numbers? Just the x values from my relation. Okay, from my set of ordered pairs. The range is all possible. It's in your notes if you forgot. Y values. So I'm looking at a -2, 0, 2, and 3. That's it. Domain are the x values, range is the y values.
Can I make the any numbers between 2 and
No, because see how that's in a set? This is just points on an ordered. I like that. I'm going to show you others too. Okay, let's look at number 2. Is it a function? Remember, to be a function, each domain has to have one range.
Yes.
So are there any repeat domains in here?
No.
No repeat domains, so yes. It has to be a function. Now, function doesn't necessarily mean good, right? I said yup. I yelled yup in my writing. The domain is all possible or x values. So what are we rocking? 1, 2, 3, 4, 5, 6, 7, 8 M's in my pen. That's a song. All right. The range is all possible what? So I got 1, 2. OCD kicking in for me. I don't like that it jumped to 5. Okay. Now, we don't need to know the equation. We don't need to know the function. We're just identifying, is it? Yes or no? And remember yesterday on that function carnival, if like cars showed up twice, there was that backtracking. That's when there was a domain with more than one range. Okay, so let's look at number 3. Function, yes or no, and why? Who can tell me? Yes or no, and why?
Yes.
Lucian.
I think it's yes because none of them overlap.
Yes, we've got 4 different domains. Each domain has one range. That is a function. So, I like going least to greatest. I just, me, I like being organized.
Do we have to?
Have to is a strong word. If I'm grading like 100 quizzes, I like to see your quizzes and be the same as my key, but The range is all possible y values. So I have 15 fourths, 17 fourths, 15 and 17. Hey, the domain and range are the same. It's kind of cool. And number 4. I'll slow down for a half second. Do you think number 4 is a function? Why or why not?
No.
Who can tell me why it's not then, Olivia? Domain -3 has 2 different ranges, so it cannot be a function. The domain is all possible x values. And the range is all possible y values. Pretty cool, huh? The first thing number 5 asks for is, what is the relation? So the relation is just going to be our ordered pairs. So I got a -2, -2, -1, 1. I've got a 1, 0. Got a 1, 1. I've got a 3, 3. Now I've got a 3, -2. So that is my relation. Relation just saying there's something happening between x and y. Here it is. It's just the ordered pairs, right?
We gotta count the last 2 relations.
Thank you. Everybody good with the relation? So the domain is all possible x values. So I got -2, -1, 1, and 3. The range is all possible y values. -2, 0, 1, and 3. So I actually you're going to draw this off to the side. I want you to draw this. This is called a mapping diagram. It's another way we look at functions. It's like 2 little boxes, kind of. And I write the domain. I write the range. And then what I do for all my points is I draw arrows for that each domain and what it pairs with. So I look at point -2, -2, -1, 1, 1, 0, 1, 1, 3, 3, and 3, -2. Yep. So this is kind of a nice visual, actually. If you're trying to decide if something is a function or not, each domain over here can have how many ranges?
1.
Yeah, and then what do you notice about domain -1 and domain 3 in your mapping diagram?
They have more than
They go to more than 1, right? So what does that tell you about function?
no.
Okay, another thing. Do you remember me talking about that vertical line test? Do you guys remember that?
Yes.
So if there's a vertical line, should you be able to go through 2 points?
No.
No, so check out these 2 spots. That tells you a domain or an x value has 2 different ranges. And that tells you it is not a function. Remember, again, if you did that in Function Carnival, you got multiple things show up. Yeah, you couldn't have multiple things. That made it not a function. Now it's still a relation. It's still a thing in math. It's just not a function. All right? I kind of like the mapping diagram. I didn't used to I'd be like, why do I need that? But I kind of like the visual because math is visual. And math is communication. And lit. And ill, fam. Ill means good in that case, not bad. Okay. Are you guys seeing that? Okay. So, the domain, let's talk. We're going to put the domain in brackets. Okay, what is the domain of this? So this is what is called, by the way, two things you might want to keep in mind. There are discrete and continuous. Uh-oh. Continuous. Is that right? Okay. There's discrete relationships and continuous relationships, okay? A discrete is going to be specific spread out points. For example, like the balance on your iTunes gift card, right? Songs are what, like $1.29 or something? So each time, is like each penny an option for balance once you start using it? Each little penny? Is $19.99 an option after you get an iTunes gift card? Can you spend a penny? No. Right? There's like defined prices for things like apps and music, right? So you jump between things. There's not every little thing in between. What about a hose filling up a pool? Continuous, every little thing between it, depending when you stop it. What about a car traveling down the road? It's distance. What about me teleporting down a road? Just showing up this spot, this discrete. Okay? I'm trying to use real world examples here. All right, so talking about this domain, what are the options? So domain is all possible x values. How many possible x values are there here, Lucian? Infinite. So good luck writing all those down unless you know math. People say you don't need math. People say a lot of dumb stuff, by the way. Okay. Anyway, so we need to use an inequality. And this is why we do inequalities before we do this. What does x need to be bigger than? Or equal to? What's the lowest thing x can be?
-2, -8.
No?
Oh no, it's
-9.
No? -5. X is the domain. This is the furthest left on the graph right here. So but it can be -5 because there's a dot there, right? So -5 is the lowest it could be. It could be big. It can be bigger than that though. It can be bigger, but what's the biggest it can be?
9. -7.
7 is the biggest it can be, right here. So it's between those two things. Do you see that compound inequality coming into play? X has to be bigger than -5, but less than 7. 7 or less. Can be -5 or more. 7 or less. And everything in between. Everybody seeing why you need that inequality there? So let's look at the range. So there's going to be y values for the range. What's the lowest y can go? -9. Right here.
No, it's -9.
-9 right here. This point right here is the lowest point. Okay, and what's the highest it can go? 9. So y can be as low as -9, as high as 9, and everything in between. This is the only way to write them all. Is this a function?
Yes.
Does each domain have one range?
Yes.
So let's try the vertical line test. Can I get that to cross 2 points anywhere?
No.
No, that is a function. Is this a function? No, because all these domains have how many ranges? 2. Is this a function?
Impossible. Most likely.
Yeah, only one. Is this a function?
Yes.
Yeah, it was a bad drawing.
Oh, okay. Yeah.
Yeah, that's okay. Cool.